So in today's video we are going to see how to create a PCB layout for a 5 volt power supply using a 7805 voltage regulator. So let's dive in. We will go straight to the video. First you go to the website EasyEDA.com. There are two options, design online and download. You can download EasyEDA and install in your computer. But I usually suggest to go for a design online because all my data will be stored in the cloud and you can access it from anywhere. So I am using this option, design online. So it will provide two options, Pro Edition and Standard Edition. Standard Edition is free. I think both are free. But I usually do it in the Standard Edition. So here is the Standard Edition interface of the EasyEDA. So in that we have to open a new project. So go to the file menu and new and click project. So there is a window for the new project. Here you enter the project name. Now we will save this project. So we will get a interface like this. Here we have to draw the schematic of our project. And in this section you can see a library. In this library you will get the components. So the first component we need is a diode for rectifier bridge. Search 1N4007 in the library, so you'll get lot of options. In that many options are SMD. We need a through hole component, so select a through hole component. So we will place this on our schematic. We need 4 diodes for this. There are 4 diodes for the rectifier bridge. To connect, here is the wiring tools. In the wiring tools, select the first tool. Connect the components by clicking and dragging them. It's very easy to do. Okay, now we have created a rectifier. For that you need a screw terminal. So go to this common library. This side you can see a common library. In that you can get connectors. There are different type of connectors. Just select this one. No, not this one. Select this. This is a through hole one. Okay, now place it here. You need 2 of them because one for input and one for output. Now we have to connect it to the rectifier bridge. Before that we will just turn it. Here you can see how you can flip it. And to change the name, you just double click on the name here and we will put it as AC input. And this is as DC out, 5 volt out. Output. Okay, now we will connect this to our rectifier bridge. So from AC connection you have to go to this point. Okay, now we will connect the other AC connection here. Okay, now we will have to bring our LM7805. Go to the library, search for LM7805. This is a SMT component, so we cannot use that. We will go for the through hole component. Okay, this one or this one. Okay, we'll go for this one. So this is our LM7805 IC. We will be converting the AC with these 4 diodes and we will be regulating it with this IC to 5 volts. Okay, so we have to take the positive. From here the positive output comes and we will put to the V in of this IC. Okay, now we will go to the output and we need the negative section or the ground section. Okay, and we connect this ground to this. So this is the regulated power supply, but the output will not be so there will be a lot of ripples in the rectified DC, so we have to smoothen it. To smoothen it we need a capacitor. So we will use a 470 UF capacitor. So how to select this capacitor? You have got lot of options, different options here. So in that, which one to select? Because we are using a transformer of 9 volt, after rectification it will be giving around 12 volts for us. 9 into 1.4, roughly 12 volts. So we need a capacitor above 12 volts. So for a safe margin, we are going to use a 25 volt capacitor. So you check any 25 volt capacitor and check the pitch. Pitch is the distance between the two pins of the capacitor. So what I am having is a capacitor with a pitch of 5. So here you can use this. This has a pitch of 5. So you can place this. And while placing this, we have to connect the positive to the top rail. So just press your space bar 2-3 times. So it will turn, and you can wire it now. So this capacitor will smoothen out the ripples, and now we have to remove some electric interferences and high frequency things which we don't need. So we will use a 100 NF capacitors, film capacitors for that. Here also you will get a lot of options. Here I will select the one with a pitch of 0.5, and we will place it. So we will place one here, and we will place one here, and we will cut it. So our schematic design is over. Now we have to convert this to a PCB. How to do that we will see. It's very simple. Go to this design option in the menu and convert schematics to the PCB. Now we get all the components. Here is your PCB board, and here are the components. We have to place the components into your PCB board. It will be just like this. See, here are the components, and we have to place it here and route it. So first we will place these two. P1 is the input one, P2 is the output, and we will place the rectifier bridge. Okay. To change the shape of the PCB, just click on the border and just drag it. We will put the regulator to the edge because we have to place a heatsink here, and these two capacitors. Okay, so when you have to change the capacitor's orientation, since these lines are crisscrossing, you just press the select the capacitor and press the space bar. The placing of the component is the most important part. So you have to change check for different configurations where you can place it correctly. So we'll place it like this, and we'll try to route it. Sometimes we again have to change the layout. Now we'll have to route it. Click the wiring tool, go to the routing width to 2 mm. We'll take 2 mm. Since we are making a single layer PCB, we will select the bottom layer. Okay, yes, like this. Now route it outside that. It won't interfere with the other components. We have to connect. There is a small problem here, so we will just move it here. So we will get a gap. Okay, these two tracks are coming very close, so we have to move it lightly here. Okay, now it is almost okay. Yes. Okay, fine. So our routing is over. Now we have to just make it clean, make the PCB look clean. So we'll just adjust all those things. So this is the final design. Now we can preview our board. Just click the 2D view. So you will get the 2D view. See, and this is the front side, and we can select the bottom side also, so we can see the tracks here. Now we will put a text in the back. We will do 5 volt regulated power supply. That just to identify when we make the PCB transfer PDF, whether it is okay or not. You have to see a mirror image of these letters in your PCB transfer PDF. Now there is only the component prefix. Now we have to put the component values if you want. So select your components and display prefix, yes. Display name, yes. So the component names will come that you can add here. Okay. Just will making this. Now the PCB is almost done. We have to mark which is the input and output. So we will do that. Go to the top silk layer. So now the top part is highlighted in yellow. This one is little down. We'll correct it. We will need two texts. We have to place it here, but the size is big. You can reduce the size here to 1.5. Okay. Now this is the out. So in this we have to mark this thing for positive and negative. So reduce the font size to 1. Yeah, that is correct. So this section is positive 5 volt and this is the ground. Now your PCB is ready. Now we will preview it. So this is your PCB, and you can change the color if you want to red or blue or green, any color you want, yellow. And this is the bottom. This is the bottom side. This is the tracks. Check for the tracks for some problems. The tracks should not touch each other. Now we will check the 3D. Checking the 3D is very important because there may be some components overlapping each other. So you can see if it is overlapping or not. Here no such problem is there. So our PCB design is ready. Now we will make a PCB transfer. After finishing the design, make sure that no tracks are touching to other tracks. There are no overlaps or no components are overlapping. Now you can make a PCB from this layout. For that, two options are there. Either you can go to a PCB manufacturing company, or you can make yourself in the DIY way. Use a copper clad board and make a PDF of this and transfer it to that. Print it out on a laser printer and transfer it to a copper clad board. If you want to make it from a company, they may require a Gerber file. For making the Gerber file, we have to go to the menu, and there is an option called generate PCB fabrication file, Gerber. Check the DRC. Now there is no errors in this PCB. That's why you get this window. If there is any errors, it will shown here. Now we can download the Gerber file from here, generate Gerber. So with this Gerber file, you can give it to any PCB manufacturing service, and they will send you the finished good. If you want to make the PCB yourself by ion transfer method, heat transfer method, you have to make a PDF of this layout. For that, go to the menu and select export and PDF. In that, first you have to make the top layer. Select the top layer and mirror it. Just unselect it, the mirror option, and select it. And press export. So you will get the PCB layout here. One thing you have to check is the letters. The component markings and these letters all should be in reverse. So once you transfer, it will be converted in the normal way. Now we will have to go for the bottom layer. Once again, unselect top layer and select the bottom layer. And this time you don't have to mirror it. It will automatically mirrored. So you get a mirrored file. Here you can check these letters for mirroring. Now you can print this out, and you can use a laser printer for that. Don't use inkjet printer. Use a laser printer for making the printout, and you can transfer it to a copper clad by an ion transfer method. There are a lot of videos in YouTube about ion transfer method. You can refer any of them, and you can easily transfer this to a ion transfer board. One thing you have to make sure that this border is not touching the tracks. Sometimes this border may touch the tracks and short it. So make sure that the border is not touching anywhere, and the lettering is also not touching anywhere. So this is how you make a PCB very easily in EasyEDA. So if you want to learn more about designing with EasyEDA, I am doing an online course which will be in Google Meet. So you can contact me in the number given for the time slots. So thanks for watching this and good day to you.